Hi guys, I'm PhotoNerd, and as you might have noticed, I have a fascination for LED string lightsabers. So this video will be also mostly about that topic. Today I'm going to show you an exciting new technique which will, I think, has the potential to revolutionize the way we build LED string lightsabers. This, what you see on the bench, is not what it looks like, a cheap discotheque lighting or a stolen neon advertisement light, but a blade of a prototype lightsaber I built. What is inside is what we've been, I think, dreaming about. An LED string with three colors, so red, green and blue, where each individual LED in the LED string can be individually programmed. So let's see how this works. So I'm going to switch on the lights again. This piece of string I hold in my hand, I think it will not be very sharp on the screen, but anyway you can see on this string you have small modules, which are the LED modules. This is so-called a Neopixel string of the type WS2812B. Never mind the name, I will basically put it into the description of this video. You can see here basically the individual LED modules, and each of these modules have an own controller using a so-called pulse width modulation technique. That means that you can fill the controller with the internet color mix using a single serial line. You can see basically that all this string needs are three lines. The black one is the ground, the red one is the VDD supply, and the green one is the one line serial communication line. So basically it's crazy, it's just three lines, and you can basically achieve this nice effect which you can see on the screen. So these LED modules are connected together with this serial line. And basically, if you want to control the individual LEDs, then you have to fill up a so-called shift register. So the shift registers of each of these modules are connected together serially. So that means that every time you see any color change here, it means that the whole string has to be filled up with a totally new set of values. Now this plate has 50 LEDs, and if you make the math, it's 50 LEDs, each have 3 times 8 bits. This 3 times 8 bits correspond to the 3 colors, the PWM register of these 3 colors. So in total you have 1200 bits which has to be filled up. And basically it all happens in the background, so to say, because looking at this very fast color change with the naked eyes, you will not see basically when the programming takes place. Now the future versions of the lightsaber operating system written by Sebastien Capou will also include later on this a kind of basic layer to drive Neopixel type LED string lightsabers, and now I will show you how it works. So I have to now load the lightsaber OS. So now the lightsaber operating system is loaded to my DIYino prototype board. So far I only programmed the kind of basic functionality like lightsaber ignition, retraction, and the random flicker, which combined with the unique sound font controlled LED control of the DIYino board gives, I think, a very realistic touch to the lightsaber blade. So let's ignite. So let's see. So you can see basically already the random flickering, which is controlled by the sound font. You can basically do most of the stuff which is also available as function to the lightsaber OS, like blaster deflect, blade lockup. The swings I'm not going to show you because I don't want to send my prototype board flying around in the room, because it really needs swing motions, which I cannot reproduce just by holding the board on the table. So some clash. And finally retraction of the blade. So let's see how I can change between the sound fonts. This should be another sound font. So this is a green blade. One. So now let's stop playing and come back to the technical details of this Neopixel LED strings. So I let run in the background the so-called fire demonstration. You can see that basically it resembles a burning fire and flames. I find it actually a very nice demonstration of this Neopixel LED string. So these LED strings actually come in many varieties, but the most common design have basically what you see here, a flexible string where the individual LEDs are mounted on. The single most important parameter of the LED strings is the density of the LED modules which are mounted on the PCB. Of course, the more LEDs you have per meter, the brighter the blade is, and it's also easier to diffuse it because of the distance between the LEDs, the individual LEDs is also smaller. Usual densities which I found so far are 30 or 60 LEDs per meter, and currently this is the most dense board I found. Probably you will not see it, but this one has this is really crazy, 144 LEDs per meter. Now, of course, as always in the world of technique and electronics, nothing comes for free. There is a trade-off between brightness and power consumption. These beasts are really power hungry. They are devouring power like hell. You can do the math. I have 50 LEDs and the string. You want white colors, you have to mix all the 3 base colors. Each of the LEDs consume around 20 milliamps. So you will add this up together, you will have around 3 ampere power consumption. Now, if you have a look at my bench power supply, I'm not sure if it will be visible. Not really. Okay, I will try to switch on the lights. Maybe it's better visible here. Yeah, it's a bit better visible. You can see that it consumes at the moment around yeah, something like 1 amp with a supply of 0.7 volt. I put out the 0.7 volt because this is the most commonly used battery together with lightsabers, the 18650 and some other variants with 0.7 volt supply. So actually these modules are rated in the manuals for 5 volt, but actually you can go much deeper with the voltage as 5 volt. You can see that it also works, that already works very good with 0.7 volt, but in fact you can also go lower with the voltage. So now let's try to simply lower the voltage. So now I'm starting with 3.7 volt, nice 3.3, 3.1, 3 volt, 2.8 volt. The only difference basically what you will see here is that of course the brightness will suffer, and that the hue of the colors will go toward the more warmer colors. That means that mostly the red LEDs will be visible, but actually it still can be programmed. So I'm just curious now. It's 2.3 volt, 2.2 volt. It gets really dim, but it's still programmed. It's 2 volts, still going down, 1.9 volt, and I stopped. Ah, no, it's still working. Oh, okay, 1.8 volt. It's still doing something. $1.7. Well, the controller works actually also with a very low voltage as it seems, so I'm down now to 1.8 volt, still not visible, unfortunately. But the module is still working, so now let's get back to 3.7 volt. Of course, since you can control the LEDs with PWM signal, you don't have to drive them to the maximum voltage, which means basically that you can set the PWM to lower value, which will basically save some power. And anyway, since there are a lot of LEDs here, you definitely will be a very bright blade even without pushing the LEDs to their extremes. So guys, I hope you enjoyed this short demo. Thanks for watching. You can find our thread in the Arduino forum, see the link in the description of the video, and yeah, enjoy the fire.